In the last video, we looked at the law of sines. In this video, we're going to look at the law of cosines. And so remember, law of sines and law of cosines have to do with solving for missing pieces of triangles and using trig when the triangles are actually not right triangles. Because when we have right triangles, we have the unit circle and we use all of those ratios, and we're able to solve using SOHCAHTOA, the ratios of the sides, and it's pretty straightforward with that type of trig. Here with triangles that are not right triangles, we can't use the standard trig. So what we're going to do is we're going to still use trig, but we're going to use it in a little bit different format. So let's look at the law of sines. Just to review the law of sines, when we review the law of sines, so let's say I have this ugly triangle here, and I want to find missing sides of this triangle. This is obviously not a right triangle. So let's say that this is angle A, this is angle B, and this is angle C. That's side A. Well, notice how I'm writing these. Lowercase for the sides, capitals for the angles. The law of sine says that I can actually use this set of ratios to solve for missing components. That's sine A over A should give me the same ratio as the sine of angle B over side B, which would be the same ratio as the sine of angle C over the length of side C. So that is our law of sines. We cannot always use the law of sines, though. If I'm going to use the law of sines, I need to either have two angles and a side across from one of those angles, or I need to have two sides and an angle and the angle across from one of the sides. When you use the law of cosines is a little bit different situation than the law of sines. So let's look at the law of cosines. The law of cosines, and hopefully you can read my chicken scratch cursive. The law of cosines looks very familiar in some ways in its structure. So a squared equals b squared plus c squared minus 2bc cosine A. Now, if you look at this, you'll see elements of the Pythagorean theorem, the a squared, b squared, and c squared. So when I use the law of cosines, I'm usually trying to find something where I don't have an included angle or the sides don't match up. There's a lot that you can use there's a lot of conditions, and we'll talk about those conditions in a bit, but there's a lot of conditions for whether you use the law of sines or law of cosines. So in the previous video, we showed an example. If you go back here, we showed an example of when to use the law of sines, and we've solved for an angle and a side, or an angle, and we solved for a side. So for law of sines, that's going to be a situation where I have something like this, and I'm looking for this one. So I have two angles and the side across. So that's one scenario where you will use the law of sines. The other scenario to use the law of sines is, what if I'm actually looking for an angle? Well, it's the same situation. I have two sides and a non-included angle, and I'm looking for an angle here. Or I could be looking for another angle and just use the formula to kind of work my way through the triangle. So basically with the law of sines, what you see here is that you need to have two sides and a non-included angle. And we love to write this as something we can't use in geometry, which is as. So angle side side would be a situation where you would use the law of sines. If you go back to the example I gave previously, and let's draw this back in there. So the example that we had previously was pretty much the same, except for I was actually looking for a side. So I'm going to erase this. Sorry, a little all over the place right now trying to solve this. So let's say I have two angles and a non-included side. So that's what I'm going to have now is I'm going to have angle, angle, side. That's another situation in which I can use the law of sines. Let's look at the law of cosines. So the law of cosines, let's say I draw another triangle here. The law of cosines dictates a little bit different conditions. So let's say I have A, B, and C, and then I have A, B, and C. Whoops, nope, that's not correct. I can't read letters. So this is C and this is B. So when I look at the law of cosines, I'm trying to find, again, something that's missing, and I'm given three components, and I'm trying to find the fourth. So if we look up here at what works for the law of sines, well, let's think about an angle included between two sides. So let's say that I have this angle is 40. And so that's 40 degrees. Let's say this side here, B, is equal to 10. And let's say C is equal to 12. Well, I've got side, angle, side. So in this instance, it depends on what I'm looking for. If I want to find side A, the problem is I don't have anything that matches up. Look at the law of sines. I could go sine A over A, but I don't have side A. I can't do sine B over B because I don't have angle B. I can't take any of those two pieces of sine, whether it be these two or these two. There's no way I can make an equation where I have three values inputted and I'm solving for another. So when you have the SAS, you have to use law of sines because law of cosines is not possible with the dimensions that you are given. So I'm going to move up here and let's look at this. Let me show you why law of sines doesn't work. Let's say I used A. I would have sine of 40 over A. I don't know A, right? Well, what if I want to find angle B? Well, then that gives me sine of B over 10. I've got two unknowns here. I don't know A and I don't know sine B. The same problem is going to happen if I try to use C. What if I change that to sine C? I don't know A and I don't know sine C. So I can't use law of sines here. When the angle's included between the two sides, you cannot use law of sines. That is why we have the two different formulas and you have to use the law of cosines. So let's use the law of cosines to solve this one. So let's say we're looking for A. Well, I don't know A. So A squared is going to equal B squared, which is 10, plus C squared, which is 12 squared, minus 2 times B, which is 10, times C, which is 12, times cosine of A, which is 40 degrees. And you can see now, all I'm going to do is one step. I'm going to plug this into the calculator, and it's going to give me a value. So let's go ahead and plug that in. So I'm going to have 10 squared plus 12 squared minus, let me move that cursor out of the way. There we go. 2 times 10 times 12 times the cosine of 40. So you can see this is exactly what I have on the other screen. 10 squared plus 12 squared minus 2 times 10 times 12 cosine of 40. Now when I enter that into the calculator, I get 60.1493. So I'm going to go back over here, and again, we don't round unless we have to. 60.1493. That's what that big string of expressions gives me. And that's all equal to the side A, whatever it is, squared. However, just like when you solve Pythagorean theorem, I don't want A squared, I want A. So I'm going to take the square root of both sides to get my A value. So let's come back over here. And I'm going to take I'm going to do square roots. So I'll be down here. control, oops, sorry, my mouse is not working. Control square root, and I'm gonna, oops, sorry, I've got an old computer that needs to be replaced. Oops, that's not where I wanted to go. So we actually went somewhere, I don't know where. 60.1493. So 60.1493. Definitely not one of my best videos. And you get 7.7556. So the actual length, normally with sides we round up to one decimal, is actually 7.8. So now we were actually able to find the length of side A using the law of cosines. Now, that's not the only situation where you would use the law of cosines. So we've got SAS. Another one would be SSS if I knew all three sides, but I didn't know any of the angles. That would be another situation where I would have to use the law of cosines, and I would find one angle first, and then I could use law of sines if I wanted to. So let's do an example. I know your head is spinning right now. So I'm going to give you another triangle, and I'm going to label this A, B, and C because we're all boring like that, which means that's A, B, and C. And I'm going to give you some lengths. So I'm going to give you the lengths of all three sides. So we're going to say that B is 12, that A is 8, and that C is 6. Oops, let's not do 6. Let's say 7. Okay. So I want to know, what is angle C? Now remember also we can call angles theta. That's a symbol you see quite a bit for theta. Well, I can't use the law of sines because remember, law of sines, if we go back and look at it, the law of sines has to do with knowing at least two of the angles before I can set up, or at least one of the angles before I set up a ratio. I don't have that here. I have to use the law of cosines. So the law of cosines, again, is, and it depends on the side. So here, I'm trying to find angle C. Now, the basic law of cosines is this. A squared equals B squared plus C squared minus 2BC cosine A. These letters can be moved around depending on what you're solving for. So in this case, I'm solving for angle C. So I'm going to take C squared and put it out here. And I'm going to put A squared and B squared on the inside. And then I have 2AB cosine C. So what you can see now is that I'm solving for the angle that's missing. I want to know angle C. C squared has to be on the outside. I do know C squared. It's 7. C, it's 7. So I have 7 squared. I apologize for these pen marks. And A squared is going to be 8 squared plus 12 squared minus 2 times 8 times 12 times cosine C. I don't know C. I'm trying to find angle C. Once again, we're going to use the calculator, and we're going to do 8 squared plus 12 squared. So we've got 144 plus 64, which I believe would be 208. So I have 208. On this side, I have 49. And that's minus 2 times 8 times 12, which is 16 times 12, which I believe is 192 cosine C. Now let's check my math just in case. So just in case, I have 8 squared plus 12 squared. Let's make sure I did my math correctly. And 208 is correct. And then I have 2 times 8 times 12, which is 192. Look at that. So now it just becomes a matter of algebra. So I have to move the 208 over to the other side. Well, in order to do that, since it's positive, I'm going to subtract it. Some teachers don't like you to write it like this on both sides. They just want to indicate the move on the one side, but this helps a lot of people. So We've got 49 minus 208, and I'm done thinking for the night. So 49 minus 208, that gives you negative 159. Now your sign is important. It is a negative 159 and it needs to stay that way. And that is equal to negative 192 cosine C. Just like algebra, we are now going to divide both sides by what's in front of our variable, 190, negative 192. This is why you can see that the sign is important, because a negative divided by a negative is going to end up giving you a positive. So negative 159 divided by negative 192, and it doesn't matter whether you put the signs on these in the calculator because they're the same sign, so they're going to end up positive. And you get 0.828125. And again, keep as many as you can. 8281. I'm going to go ahead and round to 4 decimal places. That's close enough. So I have 8281. Now you're presented with the issue that we want the angle, not the ratio. So we're going to use inverse trig. So I'm going to move the cosine over. And again, you may have seen it written arc cos. Arc cosine is the same as inverse cosine, but I'm going to take the inverse cosine of 0.8281, and that's going to solve for angle C. So I'm going to do inverse cosine, trig, inverse cosine, 0.8281, and that's going to give me 34.1. So angle C is actually 34.1 degrees, and you've just used the law of cosines to find angle C. Once you get to this point, if you have to find the rest of the dimensions of the triangle, you would, at this point, now that you have one angle and you know all 3 sides, you could use the law of sines, which is actually easier to find the remaining angles. Or you could do law of cosines again. The important thing to remember is that all angles in a triangle add up to 180. Once you know 2 of the angles, you can figure out the third. So once again, that's how to use the law of cosines in triangles. And remember the rules when you use law of sines and law of cosines. There are specific sets of rules that you have to follow in order for those to work. Law of sines, that's when you have 2 sides. Hopefully you can see my cursor. 2 sides and a non-included angle, or 2 angles and a non-included side. That's when you can use law of sines. Law of cosines is when you have all 3 sides, or you have an angle included between 2 sides. And that should help you solve your triangles.